Hello, my name is Seongjin. It is my pleasure to present my paper at this conference. The title of this paper is Design and Simulation of a Safe Truck Cargo Matching System for Rollover Prevention. I will start the presentation. The table of contents is as follows: Introduction, Related work, Proposed system, Mathematical model, Simulation, and finally conclusion. First is the introduction. According to traffic accident statistics in 2021, the number of rollover accidents of passenger cars and trucks occurred 390 times and 146 times respectively in Korea. If we simply compare the number of accidents, the number of trucks seems low, but considering that the number of vehicles registered by truck is 18% of passenger cars, we can see that trucks have a high accident rate. In addition, more fatalities were reported in truck overturn accidents. On curved road too, it can be seen that truck accidents are more dangerous. Therefore, various efforts and research on measures are needed to prevent truck accidents. One of the causes of truck accidents is the height of the center of gravity. Commercial vehicles such as buses and trucks have a higher center of gravity than passenger cars. When carrying passengers or loading cargo, the center of gravity is higher and is more affected by lateral force. As such, the risk of overturning is high, and in the event of an accident, it is easy to cause a major accident. Rollover accidents commonly occur on curved roads, such as highway ramps. It is particularly prone to accidents on steep bands or downhill. Therefore, it is necessary to reduce the lateral acceleration applied to the vehicle on a curved road. There are methods such as passing through a dangerous section at a low driving speed and lowering the center of gravity by avoiding overload. Related work. The main factors affecting vehicle rollover were the center of gravity height, the horizontal distance from the center of gravity, and the vertical drag of tires. The National Highway Traffic Safety Administration accepted General Motors' opinion and established safety evaluation criteria using a static safety factor model. The SSF of a vehicle is an at-rest calculation of its rollover resistance based on its most important geometric properties. Basically, SSF is a measure of how top-heavy a vehicle is. A vehicle's SSF is calculated using the formula on the right. This study proposes the safe truck cargo matching system with the aim of creating a safe driving environment for vehicles and distributing them reasonably. Some working level officials have difficulty selecting vehicles, Accurate dispatch is further required because transportation costs should be reduced while selecting a means to transport goods safely. In the case of junior, there is a greater possibility of misallocation due to lack of experience. So quantitative calculation based on data is more effective. This system determines the loading possibility based on information such as the size and weight of the cargo or loading model. It also calculates the center of gravity of the loaded vehicles to evaluate safety and determine whether it can be driven. Among the evaluated vehicles, recommended vehicles with high stability and vehicles that can be loaded but require attention in transportation are all put together. When dispatching vehicles, the person in charge can make a reasonable decision by comprehensively considering the output result, transportation time, cost, etc. When the information of the cargo is input, it is compared with the information of the vehicle stored in the database. If it is impossible to load due to the size of the loading box or overweight, it is determined that the loading is impossible. And if loading is possible, the changed center of gravity is calculated in the loading situation. In this step, the possibility of overturning the vehicle is evaluated based on the predetermined driving environment. If the evaluation index exceeds the critical point where the rollover occurs, it is judged as a dangerous environment and the vehicle is declared unable. If it does not exceed the critical point, compare it with dangerous point and determine if driving is possible. If it exceeds the dangerous point, it outputs transportable with caution and calculations are performed for the upper model. If it does not exceed the dangerous point, it is judged as a safe vehicle. Recommended will be printed. The following is a mathematical model formulation for the evaluation of rollover potential. The position of the center of gravity indicated by the blue dot is higher in the loaded state than in the unladen state. The center of gravity coordinate G in the loaded state can be obtained from the equation on the right. M is mass of truck and cargo. Y and Z are the coordinates of the center of gravity. The lateral force applied to the vehicle is determined by the mass M, the turning speed V, and the turning radius R. Torque is the difference between gravity and lateral force multiplied by distance d. And LTR can be obtained through the ratio of the torque with a plus sign to the torque with a minus sign. When the vertical reaction force of one wheel becomes 0 and the LTR becomes 1, wheel lift occurs. At this time, assuming that the tilt angle pi is small, delta y can be approximated as 0 and LTR can be rewritten as index R. Next, simulations and discussions. The specifications of each vehicle by tone class were referenced in the catalog of automobile manufacturers. And in the simulation, the specification of the vehicle were applied as shown in Table 1. The driving conditions were set based on the turning radius and speed of Dongtan Junction in the Korea. The turning radius is 55 meters and the vehicle's driving speed is 40 km per hour. For index R, 0.4 or more was set as caution and 0.5 or more as rollover in consideration of external factors such as crosswinds. The cargo is assumed box type with uniform density. One cargo is loaded, and the center of gravity y coordinates of the loaded vehicle is located in the center of the vehicle. The input values are given as in Table 2. Table 3 is the result of Table 2. The one-ton truck was judged unable because it exceeded the allowable load weight. And the 2.5-ton truck was judged caution because it could load both size and weight, but the index R was 0.41. Since the 3.5-ton truck is the smallest vehicle whose index R does not exceed 0.4 among the loadable vehicles, it is output as a recommended vehicle. In condition 2, only the size and weight of the cargo were changed in condition 1. According to Table 5, trucks with less than 11 tons were considered unable because they did not meet the size and weight conditions. Both 11-ton and 25-ton trucks have an index R of less than 0.4 and can be transported reliably. But you can see that the 11-ton truck, which requires less cost, has been declared recommended. The user may select an 11-ton truck based on the corresponding result. Finally, the conclusion. We identified vehicles that can drive safely and reduce transportation costs. It was determined whether they could be loaded and evaluated the possibility of overturning. Simulations were conducted in several limited assumptions, but when vehicle screening was ambiguous, it was possible to determine which vehicles needed attention, and the results of recommending low-cost vehicles were obtained. Users can check whether cargo can be loaded through this system. Users reduce AS costs caused by unexpected delivery failures. The accident rate can be reduced by creating a safer driving environment. As a future study, it is necessary to add and modify factors that cause overturning in consideration of various loading situations. This concludes the presentation. Thank you.